In this video, we are going to talk about our final project for the subject of Calculus 3, Fall 2018. The purpose of this project was to label and measure the wind magnitude and direction in a particular location inside the institution of Arkansas State University, Campus Querétaro. For our purposes, we decided to measure the wolf which is in the middle of the school, the one that is nearby the cafeteria, the Student Success Center, the future library, the classrooms and labs, and the residency. We decided to do this because in that spot is where many civic ceremonies are engaged. Besides, we can take that as our point of start for getting all our measurements, and from there use the information recorded for a particular application. We decided to engage or focus on applications in the future constructions that will be held for next phases in the institution. But first of all, let us introduce ourselves and who we are. My name is Kevin Ramirez Chavez and I am studying electrical engineering.
My name is Ricardo González Cano and I am studying mechanical engineering.
My name is Enrique Gomez Jackson and I'm studying mechanical engineering.
My name is Ricardo Paredes Resendiz. I am studying mechanical engineering in Arkansas State University.
Well, now we are going to explain the materials used for this experiment or project. First of all, the first thing and the main component to develop this project was what we can observe here as an anemometer. The functionality of this tool is to measure the wind speed. How is this measured? Well, this is a rotational element that by putting it into a base, it will allow us to measure the revolutions that this thing does thanks to the wind speed. So this material was used in using recycled materials. As we can see, we use cups, we use sticks and cord along with tape to create our own anemometer.
Secondly, the other tools that we use to be able to measure the direction of the wind were these two. We began by using this, which is just a stick with two pieces of cloth. As you can see, it is very loose, so it is quite easy for it to show the movement of the wind. Then we moved on to this stick that has a green paper mache attached to it. This one is a little bit thinner, so it is easier to point exactly the direction on which the wind is moving. Contrary to these ones can move all the way around, and this one has a little bit more of difficulty, but it's better because when the wind hits it, it will be in a straight line, and then we can use a compass to show exactly the direction upon which the wind is blowing.
To measure the direction of the wind, we use an application of a compass called Brújula Cero 3D. The direction was pointed at us by the flag, which will go in a way. Then we will put the phone below the flag and we will measure the direction with respect to the north.
We did our measurements on the week of October 22nd to the 26th, Monday, Wednesday and Friday at 11 a.m. and Tuesday and Thursday at 3 p.m. Also, we want to clarify that we changed our measurements from revolutions to meters over second, and from degrees with respect to the north to degrees with respect to our reference, which was the face of the wolf. We did all this to have a better mapping, and the time frames were chosen for our applications, which will be later explained.
In our place, we have this face, so we choose 18 points to measure the wind. The 2 points in the ears, the lower part, here in the middle, the front, here between the two eyes, these points in the eyes, the nose, the teeth, and these 5 points in the beard.
Monday at 11 a.m. Tuesday 3 p.m. Wednesday 11 a.m. Thursday, 3 p.m. Friday, 11 a.m.
As part of the development strategy for the university, you're gonna build the second stage in a couple of years. Now this stage is going to include a huge library, the one that you see here, which is gonna be focusing on developing abilities for students so they can study and prepare better. Now the curiosity with this library is just that it is 50 yards away from the spot that we chose to measure the wind. This is important because here we can find a clear opportunity to be innovative and to create something different, something new that is not yet seen across Mexico. Since both are the same altitude and it is just a little bit apart from one another, we have the possibility of installing systems that will produce energy. Now the system that we specifically recommend is the wind turbines called Sauvignon that will be explained later on by my partner Kevin.
As my partner Jackson already explained, our idea is to put some Sauvignon wind turbines here in our library. What is the point about this? Well, the main topic or the main theme that we want to engage by having this idea or this application using vector fields was that by using the wind speed that is located in our point or our section that we measured, we can establish or assume a similar wind velocity or speed in this direction, meaning that we can include these turbines, which are small ones, not the aeolic one that has like these blades, but some ones that have a different kind of blades, which are more or are capable of having a better flow with the wind magnitude that we obtain through our measurements. But this idea is to make our library more efficient in a way regarding the cost of maintaining energy and electricity. So by implementing this idea of the wind turbines, we can make our library more innovative in a way that it's going to look better, and it's going to be like a proposal to make some other areas around campus for next phases that are planned, having sustainable energy resources or renewable energy, so we can make some other buildings having this same technique or method to supplement the energy or electricity of our buildings.
Another application of our measurements is to do a public ceremony. Our measurements were done in this area, so we can assume a public ceremony could be there because the flags are located there. We have done the measurements in 5 days in 1 week. 3 were at 11 a.m. and 2 at 3 p.m. Those measurements vary between the hour, so we can assume and we can confirm that the best time to make a public ceremony is at 3 p.m. though the wind is lower, so we can have better performance of the public ceremony.
Thanks to this project, we got a better overview of how calculus is applied in the real world. We also noticed that vectors are incredibly important in the analysis of projects or applications. The applications we mentioned are an opportunity to collaborate within our community and leave our mark here in our university.
We would like to thank Arkansas State University Campus Querétaro for lending the facilities where experimentation took place. Also, Fernanda from Deshury, which lended the renders used in this recording. We would also like to thank Dr. Maria Juarez because she taught us about the vector fields and all of the things that we use to make this project.